Hello, everyone. Good afternoon, good evening, welcome. Yesterday, we had a wonderful office hour. Wonderful, wonderful. We did a great chemistry. We did review the nuclear reaction, how to balance it. We did electromagnetic radiation. We did the wave property and the particle property. Did you remember? It's wonderful, wonderful one. Now, listen. This coming Sunday, we will have a final quiz and the final exam for chapter 2. This Sunday, we will not have office hour. So next Sunday, we will have office hour. Now, following Sunday, we have the first quiz of chapter 3. That's our class about, okay? We are going to we are learning, we do the homework, we practice, we have a quiz, we have an exam. Remember, this is Sunday. Now, if I were you, after class, I'm going to review chapter 2. So it's one quiz, one final exam. Good luck. Open your class notes. Open your class notes. So we are going to, did you remember until this point, what we did? So we did electromagnetic radiation. We said light. Basically, light is what is electromagnetic radiation or wave. You have wave property. Right? And also we discussed the quanta. Did you remember the quanta? Let's go back. Let's go back what we did. See, that's quanta. Now, why we have a quanta? Because the light also has particle property. Light has particle property and the wave property. Now, wave property, you have a wavelength, you have a frequency, you have a speed of the light, and you have energy. Or also you have, for the wave, you have a diffraction. But when we use wave property to explain something such as blackbody radiation, and that way, when we use wave to explain, wave failed us. So that Max Planck proposed the quanta. The quanta, okay? And the quanta related to what? Quanta that related to particle. Wave and the particle, okay? Wave and the particle. Now, remember, the quanta come from what? Such as we are going to explain the hydrogen gas lamp. That's the quanta. See, matter can absorb and release specific small amount. Remember, specific small amount. Small amount of specific. That's one. The second one, it is a whole number multiple. It is a whole number multiple. In other words, it is E equal NH nu. N can be 1, 2, 3. Cannot be 0.75. No. Just like atom. We learned atom, right? So do you think we can have a 0.75 oxygen atom? No. Oxygen atom can be 1, 2, 3. It's the same thing. It is the same thing. So that's the quanta. That's what we learned, right? So we can calculate, easily calculate the energy. How can you calculate? E equal H nu. H nu equals C divided lambda. So HC lambda. In this equation, and we know H, it is a constant, Planck constant. C, speed of the light. Lambda, it is a wavelength. Electromagnetic radiation is a wavelength. And yesterday, did you remember yesterday I reviewed? Basically, so far we did number 1, C equal frequency times wavelength. Wavelength equals C divided frequency. Frequency equals C divided wavelength. We use this one, repeat. The second one, we calculate the energy of the quanta. E equal H nu HC lambda. That's what we learned. That's what we learned. That's a homework, last week homework. Very challenging. But for those of you, I can say 90% of you did very well. Follow the instruction step by step. You write the equation, then you put the number, then you do the calculation. You pay attention to the significant figures and also unit. Did very well. Look at your score. Right? I'm very pleased. So which you tell me, class getting harder, you can do better as long as you wanted to do that. Now, if we do not want to do that, of course, that's your problem, okay? Now, go to page 13. Then we are going to continue working on the quanta, working on the particle, okay? Right? We are continuing to do that, okay? We are continuing to do that, okay? Right, so you go to your page 13. Go to your page 13. Now we are going to discuss photoelectron effect. Photoelectron effect. Now, so what we did? The quanta, it is a theory. The quanta it is a theory. See, E equal H nu HC lambda. I'm going to write it one more time. So when we do science, any new theory have to be tested by experiments. Agree with me? So in the future, such as you propose a theory, you propose something, then you know what? You have to do research, do experiments. Research, do experiments. You are going to conform. Exact ring. You need to prove it. Totally agree. You are good. You are good. Okay? Now, Einstein proof the light also have particle property. How did it? This Einstein photon electric effect won the Nobel Prize. So we are going to discuss Nobel Prize experiment. Repeat, in the next 30 minutes, we are going to discuss Nobel Prize experiment. Yeah, it is amazing. Now let's do that, okay? Let's do that. So what we did, everyone know Einstein, right? Albert Einstein, right? Who won the Nobel Prize in 1921 For what? Photon electron effect. We are going to discuss it within 30 minutes. I want everyone, you pay attention. You should be able to understand. No, it's not like, yeah. In that time, people may not understand. Now, you should be able to understand within 30 minutes. It is amazing. It is amazing. Now, let's do that. How Einstein did. What he did is he chose a metal. See? He chose a metal. And we know. So that's very simple one. Let's look at the metal copper. Copper is a 29. How many electrons? 29 electrons. 29 protons. Atomic number is 29. Protons and neutron. Where is the proton? Where is the neutron? And that one in the nucleus. In the nucleus. Very good, Eric. Very good, Rylan. Very good. Now, electron surrounding positive nucleus. Electron is negative. So there is a force, attractive force, attraction between positive proton, negative electron, so that electron want to go away. It's possible. It's possible, but it's not easy. Good with me? You want the electron simply go away. No, why? What happened? The positive is attracted by the negative. Do not go away. You understand this one? Very simple, right? Everyone knows this is very basic science. Now look at it here. So what we did? He chose metals, and actually he chose metal silver. If we look at the periodic table, silver is a 47. 47, and let me double check it, okay. You do not need to memorize now. You just look at 47, that's right. You have a 47 proton, you have 47 electron. Of course, that 47 electron, it's two types electron. One is called the core electron and the valence electron. We will discuss in a couple more classes. So valence electron is 11 valence electrons. You have a 46 core electron. 11 now, 36 core electron. Now what he did? He used the light. He used the light. And we discussed in the previous class, the light has NH. Did you remember? Eric, now it's the summer. If I said lunchtime, Eric, you do me a favor, you go to my backyard. Not under the tree. I want you to stay 20 minutes. And you will say, you are touching me. It's too hot. I'm sweating now. I understand. Why? The sunlight, it is electromagnetic radiation. It's energy, which is E. H. So they use the sunlight to shine in the surface of metal. Now, he tried to find out what will happen. He found out if the wavelength of light, not the wavelength, frequency, also we can say wavelength. So if we say C is what? C lambda, that's wavelength, that's frequency. So both ways okay. Both ways okay. So when frequency is not high enough, not high enough. In other words, frequency less. What's this? Knots, which means threshold of metal. Given the metal have a different threshold. When frequency is less than the minimum, the frequency required to eject electron to overcome attractions between positive nuclei with negative electron. Nothing happened. No electron eject. That's the first thing he found. I'm going to repeat. So Einstein chose silver metal. Use light to strike the surface of metal. And he found out observation. And they see no electrons are ejected. On this, the light frequency above certain threshold frequency of metal. And that we set new knots. So when new from that one from the light, that's new knots. That's for the metal. No electron ejected. So that's the first thing he found. So that makes sense too. Think about it. Because the attraction between positive nuclear and the negative electron, you have to have minimum energy from the light to overcome the attraction between nuclei with electron. So no electron come out, okay? Now go to next one. See, when low frequency, as we know that the energy, it is directly proportional to frequency, which means low energy. Now, nothing happens. See, nothing happens. However, when high frequency, high energy, high frequency, see, what's this? Electron come out. And that we give a name, not only called the electron, we call it photoelectron. Photoelectron. Right? So, got it. Now, give me time, please. Give me couple more minutes. Give me time. I have to finish. Right? So, for example, no photon electron are emitted from zero when the frequency of light less than this one. Regardless how strong, how intensity of the light, that light is very bright. Amplitude is very high. No photon electron. Now, before I move on, I want you to calculate what's the minimum energy. Calculate a minute. What's the minimum energy, please? Calculate, please. If you have an answer, send it to me. Thank you. Good job. Good job. Excellent. Perfect. 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 Very good. Very good. Okay. Right. Now I'm going to do that. So H nu equal what? 6.626 times minus 34 joule second times 1.14 times 15 1/2 Right. Now you have 3 seconds in the figure. You cancel the second. The unit is a joule. So you should get 7.55 times minus 19. What's mean? Which means in order to eject electron from metal, that's the minimum energy required. Minimum energy required. And that we give a name. That we call the work function. We call the work function. So we use phi, and that called H nu lots. The minimum energy required, that's the one. Now, when the frequency of the light greater 1.14 times 10 to 15 hertz, even that light is dim, DIM, like evening, 9 o'clock, 10 o'clock, now, right now, probably is 10:30. Even very amplitude is very small, very weak. Photon will emit. Now, you ask me what happened now after. I'm going to repeat this experiment. Einstein used light to strike surface of the metal. And he found out he did 2 observations. Then first one, when the frequency of the light is less than the threshold of frequency, even that light is very bright, no electron come out. No electron are ejected. Number 1. Number 2, when the energy from light greater than the threshold frequency of metal, even light is very dim. And so we have electron come out. See? Electron come out. Did you see here? And the electron come out, they have called the kinetic energy. That the electron have a kinetic energy. What's the mean kinetic energy? Kinetic, which means it's motion, moving. Kinetic energy, Ke, how I can do calculate? It is 1/2 MeV squared. Now I'm going to write it better, okay? If you haven't learned kinetic energy, now we are learning now. It is 1/2 M, it's a mass E is the electron. you times v squared. V, it is the speed, velocity. That is the kinetic energy, okay? Now, if you never learn kinetic energy, that's the kinetic energy, okay? Right? So, now, when electron come out from metal, and the electrons are moving, motion, so that they will have energy. That energy called kinetic energy. In the future, when electron attracted to the nucleus, and that's called potential energy. Potential energy, which we call the bonding. Bonding, kinetic energy, motion, moving. So we introduce kinetic energy. Again, 1/2 times mass and velocity squared. Velocity unit is the same as the joule. Did you remember? SI unit energy is a joule. That's why first class we learned that it's a joule. Right? It is a joule. Now, what's the joule? Mass is a kilogram. Velocity is a meter per second, but it's a square. So which means that the unit should be joule. It's a kilogram meter square s square. Second square. That is what it is, a joule. If you forgot, you go back to review the first class. The first class. It's April 13. Okay, now we done it. Huh? We done it. Okay. Joule. Oh, see, here is a joule. Right. Now let's move on. Einstein photon electron effect. See, when light, the frequency great than threshold frequency of metal, the kinetic energy emission electron increase with what? With the frequency. Now, give me a minute. How did you get this conclusion? Kinetic energy, which means it's a motion. Kinetic energy equal 1/2 mv squared. Now, really want to look at this one. Look at A. What's the mean A? A tells us energy conservation. We learn in the chapter 1, the mass conservation of any chemical reaction. Repeat, mass conservation of any chemical reaction. The mass of reactants equals the mass of the products for any chemical reaction. Energy also conservation. See, what's the mean conservation? From here to here. That's the energy come from the photon, basically from the light. We give energy to the metal, okay? But so that one we call the h nu from the light. H nu from the light is from here. And that is h nu from the light. And that energy, they did 2 jobs. They did 2 jobs. The first one, it is overcome the attraction to remove electron, the minimum energy required to remove electron, and that's called the phi. We call it work function. The minimum energy required. Now, the leftover, the second part is what? Now you have leftover, that's the total energy, right? You only use the partial. Another part is what? That one electron will come out from metal with the kinetic energy. Did you see? ME, mass of the electron. So electron conservation equal what? H nu equal kinetic energy of electron, put E here, plus H nu naught, minimum energy required to overcome attraction, energy conservation. Now I'm going to symbolize this mass. Kinetic energy electron equal 1/2 mv squared. Right? Equal what? Equal H nu minus H nu naught. Right? H nu and H nu naught. So that's the equation. This equation we call the Einstein equation. Einstein equation win the Nobel Prize. Einstein equation win the Nobel Prize. Now I'm going to do the math. Before do that, let me do some review. Y equal ax plus b. Have you learned this math? I wish you learned. So you are in the 7th grade, 8th grade. Yes? Now? You did? If I said here is a y, here is x, do you think what's this? And that is a b. What's the slope? What's the slope? Slope is a. It's not minus a, it's a. Slope is a. Got it. Got it. Right? Got it. Okay, now I'm going to do this one. So in the y-axis, we use the kinetic energy. And here is a frequency. That one is a frequency. Oh, hold on. Oh, slope equal a. Equals a. That's right. Now in this one, I'm going to expand. Okay, I'm expand. That's right. Yeah, that one, because a could be negative, right? In this case, should be negative. That's right. Got it. Now tell me what's the slope? Slope, can I say it's h? Can I say slope equal h? Can I? Yes. Now, can you tell me what's the h? What the h belong to? Planck constant. And that's why it is a Planck constant. Right. Now, what's this? And that one, can I say equal h nu naught? Can I? Now I'm going to do another one. Yeah, this way is okay. Now I'm going to do the better. Okay, I should use ruler. Okay, yeah, close enough. If this one is A, this one is B, what's the relationship A and B? A and B, can I say parallel, not equal, parallel? Parallel. Why is it parallel? Because slope, it is the same h. Now in this one, so this A, let me do this way, okay? Let me do this way, write better, okay? This one H. Now, can I say H naught B? Can I? Can I? So that's the line. AB is the line A parallel line B. So this way write better. Okay, otherwise get confused. Right? That's confused. But the slope, both slope is the same H. Now, tell me. So in this case, which one? Line A or line B require more energy to eject the electron? A or B? B, right? B, right? B, right? Got it? Yeah, it's a B. So the attraction nuclei to the electron, B have a stronger attraction, A have a weak attraction. B require more energy, A require less energy. Got it? And that it is Einstein equation. I'm going to write it here, then we go back and look at the class notes. Einstein equation is what? Kinetic energy equal 1/2 me v square equal h nu naught. So what's this? That is a work function. The minimum energy required to remove electron. Different metals have a different attraction so that work function is different. If attraction weak, remove electron requires less energy. Got it? So this is Einstein equation. Let's move on. See here you see very well. You have a 3D graphing. We discuss A. It is energy conservation. We discuss B in the left side. See, here's kinetic energy, EK. Right, now what's this? Sodium 1A. Sodium. Second one is the potassium. Next one is the rubium, which require less energy. Energy, that one release less. Now next one is the potassium. Sodium release more energy. We are going to discuss. Give me 2 more classes. Right. So you can calculate it. See, you can calculate what's this. And here, this one is a 5.05 times 10 to 14 hertz. This one is a 5.44. This one 5.56. We can do the calculation. We can do the calculation, okay? Now, here, look at it. So what's this? That's the slope. What's this? And that's the work function. That's the work function. Got it. This is amazing. This is amazing. Wondering Einstein won the Nobel Prize. Okay, now let's move on. Let's move on. Remember this is 3D graphing, okay? Right? No, you do look, this one probably not related to mass. This is not related to chemistry, related to mass. Right? You look at this one, you look at which one is bigger. So this part is bigger than this part. What's mean? Which means, what's this? That is work function, the minimum energy required to remove electron. Got it. Right? Einstein equation we just did. See, that's graphing is here, graphing here, here. Give you 3 graphing, okay? Right, now let's move on. Now that's how Einstein explained. Einstein postulate. the light consistency, the 4 quanta. See, quanta originally proposed by Planck. Quanta basically is what is a particle. Quanta, the energy proportional to the frequency, the C. Now, Einstein used this concept to explain the photon electron effect. See how Einstein did. When frequency or energy photon from the light striking on this metal below the minimum value, no electron eject. That makes sense. Because the attraction between electron and the photon, right? So that is we call the threshold level. However, when enough energy transfer from photon to the electron overcome attractive force, that force hold the electron to the metal. So in other words, that energy, the minimal energy necessary to eject the electron, that energy we said called work function. Phi, work function is the lowest energy required. For the group 1A, alkaline metal, we learn chapter 2, 1A, and the group 2A should be minimal. Why? The easy lose electron. Easy lose electron. We will discuss more. See, look at the table. I give you the table. So here's the element. Now here is the work function, okay? What's mean work function? The lowest energy or the minimum energy required. So look at 1A. The lowest should be cesium. The highest in this one should be sodium. 1A lower than 2A. Right? Einstein assumed electron is locked from surface when atom absorbing a single photon light. And that photon must have enough energy. Single photon light, single photon. This is very important, which means a photon, it is a whole number. There is no 0.5 photon. There is no 0.75 photon. It's a whole number. Could be 1, 2, 3, 4. E equal NH nu. It's a whole number. It's a whole number. So here explain the minimum frequency. If photon, you have a more than minimum energy. So what will happen? Electron come out with kinetic energy. Electron will come out with the kinetic energy. That's the Einstein equation, which is kinetic energy of electron equal h nu minus h nu naught. Now look at the second one. Now, before go to second one, I want to give you from different angle to explain why I have a minimal energy, such as that's my window. That's my window, okay? I want you, anyone, let's look at Steven. You use 1,000 ping pong ball to strike my window. What will happen? Steven, you use 1,000, 10,000 ping pong ball. Will block my window? I don't think so. Use a ping pong ball to strike, nothing will happen. Nothing will happen. Believe or not, do that. I promise you, I will not call the police. I will say lots of fun. I will say lots of fun. Do again. If you use 10,000 ping pong ball to strike my window, nothing will happen. Why? They do not have a minimal NH. However, if you use the baseball, not 1,000, only one, you will block my window. See it? Yeah. And that exactly happen here. See? Block the window. So what's the mean? See, that's you have that, and only one baseball, you have enough NH. So that's exactly like here. See? Before you did not reach the threshold NH, even you have a light is very, very bright, the amplitude is very high, nothing will happen. However, once you reach this point, and electron come out, now if it's a light is very strong, you have more electron come out. If light is weak, you have less electron come out. Those two pictures, it's a beautiful picture. It's a beautiful picture, okay? Right, so see, a glass window could be broken by a single baseball. You 1,000, 10,000, that one will just bounce back, okay? So however, when you reach this point, reach the threshold, the bright light will cause more electron eject. However, the kinetic energy only related frequency. Kinetic energy again equal h nu naught. See, only related frequency. Right, that's done. So we finish photon electron effect. We finish it, okay? We're done. We're done, okay? We finish it. Now go to sample one. Go to sample one. Today's class is lots of fun. I want after the class, you're going to review it, okay? Now go to sample one. May I give you 2 minutes? Yeah, 2 minutes, please. Thank you. Thank you. Good job. Thank you. Okay. Most get it right. Now I'm going to do that, okay? Now remember what's the mean work function? We said it multiple times, right? Work function C. It is 283 kJ per mole. What's the minimum frequency? Okay, because the work function is the minimum NH required. V equal h nu naught, okay? And phi equal what? 298, you times the third, you get a joule. And more, 1 mole equals 6.022 times 23. And that is what it's a photon. Did you remember 1 mole? We will discuss more in the chapter 7, but we then chapter 1 more is SI unit, amount of a substance. so that we can calculate the E of 1 photon. 1 photon. Now you do the math. You do the math. You have 3 skin in the figure. You get 4.70 times 10 to the minus 19. It is 1 of photon, which equal what? Equal h nu large. And that equal E divide h. E equal what? 4.70 times 19 joule. 6.626 times minus 34 joule second. And you cancel the joule. The unit equal what? Equal 1 over second. That is the hertz. Now, 3 second unit figures. So you should get 7.09 times 10 to 14. That your answer. Okay, got it. So when you do homework, I really want to do this way. I really want to do this. Why? Why? So when we're doing this, that will help you build your critical thinking. You will be better than your AI. Thomas, believe me, you were better than AI. AI just a machine. If everything we do not use our brain to thinking, to do the critical thinking, we will not become smarter. We will become dummy. You know the words mean dummy, right? Yesterday I had a phone call with a parent, with one parent, and he asked me opinion. What do you think? Do you encourage students use AI, do the homework? I said, no, I'm not encouraged, and especially in your age. I do use AI. When I use AI, most AI help me to typing because my typing skill is very slow, okay? Worse than you. Yeah, to help me improve my efficiency. Do I use AI check something? And I know that 8 out of 10 times that conclusion is not correct. So I will, to be honest, as your teacher, I will not encourage you use the AI. I will encourage you just like what we did. We do here. So you have an equation, work function. What's the mean work function? That's the minimum energy required. Then you put the that's one more. You divide Avogadro's constant 6.022 times 2023. You find energy for 1 photon. Right, energy 1 photon. Now you get what? Then you get your final answer. Okay, got it. That's the final answer. See, that's the final answer here. So you want me to write it one more time? That should be 7.09 times 10 to 14 hertz. Okay. Yeah, please, you do your homework. As you know that. I said yesterday, right? No steps. Your score, your grade automatically is a B minus. That's it. If your work only have a number such as sample 1, what's the frequency, minimum frequency? You said 7.09 times 14. Even this number is right, you automatically is a B minus. If you step by step, even this number is not right, you will be A minus. Why? The purpose training you thinking, logical thinking. You just do what? You are practice your muscle, brain muscle, right? When you muscle, more you use it, and they get used to it. And in the future, as every seems something is new, and your muscle will have a positive response. That's the way it is. You know the sports, right? Sports practice your muscle. Learning plus your muscle in your brain. If our brain never use it, we will not become smart. We're not. We will become dummy. Go to next one. Go to next one, okay? Give you 2 minutes. Two minutes. Yeah, quick. Thank you. Thank you. Thank you. Good job. Now I'm going to do it, okay? I'm going to do it, okay? Very good. So basically what you needed to do, you just assemble to the calculation. After you did the calculation, and then naturally you will get the conclusion. Okay, so here, what's this? And that is a work function. That is a work function, right? So what's mean work function? Which means it is a minimum energy, right? See, basically it's 350 kJ per mole. Now what's this? That's the light we provide. So we can do two things. We can from work function calculate the wavelength. That's one way. Then you compare the wavelengths, with 390 nanometer. When wavelengths less 390 nanometer, and we say yes, because the NH is inversely proportional to the wavelength. That's one way to do that. The second way to do that is that from the wavelength, we can calculate the NH, which equal HC lambda U times NA and more. Then we compare with 350 kJ per mole. Both way. Now, if E, that energy great than 350 kJ per mole, so which we said yes. Otherwise, it's no. Do you think when you do question like this, you said, oh my God, one so good. I can thinking to solve the problem. That's the way we learn, right? Now let's do that. Doesn't matter which way, such as you do this way, okay? We do this way, okay? Now, how can I do that? I mean, right here, detail, okay? E equal what? HC lambda NA. Why use NA? NA called Avogadro's constant. It's 1 mole. That equal what? 6.022 times 23 more. Okay. Now let's do that. Once you have an equation, then you put the number. The number is 626 times 34 joule second. Then we times 2.9979 times 8 meter second. Now, next one, the wavelength is 390 nanometer. We need to convert to 10 to minus 9 meter nanometer. Now, in this one, you look at, so you do cancel this one, you cancel this one, you cancel this one. Your unit is a joule. That's the exact this one. How many second in the figure should it be 2? Because that 0 is not significant. Why? There is no dots. Now, when you calculate and the letter energy is less, you did not kJ, it's a joule. Now you less what? 300 times 3 joule more. Or you can do this way, 3.5 times 5 joule more. You do math, okay? You will less. So which means no. That light, not energy, not enough. Electron will not come out, okay? You got it. So many ways to do that, okay? Now go to next one. Go to sample 3, give you 45 seconds. We have lots of fun. Today we have lots of fun. Very good. Very good. Good job. Good job. Okay, very good. Yeah, very good. Yeah, very good. Okay, I'm going to discuss, okay? So here, you do not need to do the calculation. We do not. We just need to compare. Of course, once we finish more, we learn more, will be make it much easier. So you have two metals. One is Rb, so which is 1A alkaline metal. One is Ag, which is a transition metal. Did you remember we learned chapter 1, okay? Transition metal. Right, and we know that alkaline metal easiest to lose electron. That one, it is easiest to lose electron. So that one is small. That is small. Now this one, transition metal, harder to lose electron. So which means that one should be bigger. Now, look at the H nu knots, HC lambda knots, and that relationship is inversely. You want which one have a longer one, you want this longer one, that should be small, So that should be RB. That should be AG. I'm going to highlight here. Okay. Right. Any question? Any question, please? Right. Cool, huh? I see your work. You did it very good. You did it very good. Now let's move on. So we have to move on, huh? Okay, what we did? We finished photon electron effect. Why Einstein? How Einstein get win the Nobel Prize? And because photon electron effect reveals the evidence, the particle property of electromagnetic radiation. Right. So we finish. The light has a duality, both. You have a particle and it's a wave. The particle related to what? Mass and the velocity. And that it is a particle. The wave, you relate the wavelength's frequency and the diffraction. Particle do not have a diffraction. Right? So we done it. And in this part, what we did, we discussed a photon. Now the question is, what is a photon? It is a particle of electromagnetic radiation. And it do have energy. That energy, how can you calculate it? We just learned E equal h nu. E equal h nu. Okay, right? So there is no mass. That's the particle. That's the photon. Now we're going to look at, does the photon really has a mass? Does the photon really have a mass? Give me a second, okay? Does mass really have a mass? Now we're going to discuss this one, okay? We are going to discuss this one, okay? Right, now let's do that. The first one, the answer is yes or no, depends. Now we are going to do simple math. This one, this class, we did not learn it. I hope if you know, it's great. If not, that's okay. We are going to learn E equal mc squared. Anyone know this equation? This one, it is Einstein energy equation. Einstein energy equation. Yeah. Now, E equal what? Equal h nu and equal hc lambda. Have we learned this one? Yes, we did. We did the last class. We did the homework. We did it today. Now I'm going to look at this one with this one. That's equal. Since here is the C, we cancel one. So that I'm going to do the mass. Equal what? Equal h c lambda. That's the mass equation. Now, what's mean? Here, photons do not have a mass in the classical sense. If photon, no moving, no wavelength, there's no velocity, no speed, of course, there's no mass. Photon has a mass, it is a relative sense. There's no resting mass. Got it. This also is a very interesting equation. Okay. Right. Any questions so far? Any question? Okay, very good. Very good. Why is no? Look at the equation. Look at Stephen. Look at this equation. Now, if rest, so do you have what's the C? Photon rest. There is no speed. Photon rest. There is no wavelength. There is no wave. Of course. What's this? That's undefined. Got it. Logical thinking. Okay. Right. Mass, yes, no, relative, depends. It is relative. There is the classical sense, there is no mass. Quantum mechanical sense, yes. You said, oh, class is hard. It is. As I said, it's not like you learn anything like science at your school, not at that level. That's why require as critical thinking, not just memorize. You will get used to it. Okay, you will get used to it. Now go to sample 1. We're going to do a lot of practice before we move on. Okay, give you 2 minutes. 2 minutes. Okay. Good job. Good job. Excellent. Excellent. Very good, Katie. 1? Are you sure only 1 photon? No. No. There are lots of photon, okay? Okay, I'm going to do that. Okay, so we had the answer here. So let's look at what's this? Basically, it's a lamp. That's a 25W. What's mean 25W? Which means 1 second, 1 W. 1 second release 1 joule. Now you have 25W. 1 second should be the total energy. I'm right here. Okay. The total energy released by the lamp, E, should be 25 joule second, because you have 1.0 second. You cancel this one, 2 second in the figure, you get a 25 joule. Now, the question is how many photon? Now, the photon has a wavelength 580 nanometer. So we can calculate E, 1 photon. One photon, right? Now how can you do that? Quanta, right? H nu Hc lambda 6.626 33 2.9979 10^8 meter second. Of course, here is a joule second. Now lambda is a 580 nanometer. Of course, you times -9 meter nanometer. So you cancel this one, you cancel this one, you cancel this one. You get what? You get a joule. Did you see? You get a joule. You just do the math. Okay. Now total photon n equal what? Equal E total. And then E 1 photon. Now you do the math. It's a 2 second in the figure 2. So you should get a 7.3 times 19 photons. Okay, that's the one. Got it. 7.3 times 19 photons. That's a lot. Only 1 second, only 25 W watts. Right? Next time when you go to the store, your mommy said, let's find a lamp. And you said, how many W, how many watts? And they said, no, at least 60, not 25, 60. Now you look at 60, only 1 second. How many photons will come out? Of course, depends the light. If a yellow light, 25, 50 should be 1.4 times 10 to 20. That's how many photons come out, okay? That's a quanta, huh? Now go to number 2. Let's do more. We need to practice more, okay? Right. Give you a minute, okay? 2 minutes, because there's lots of calculation. You did a pretty good job, my friend. Eric, you say you don't understand? You did a pretty good job. Good job. How many seconds in the figure, please? How many? 2. That's right. 2. Not 3, 2. How did you get a 2? See? Good job. Good job. Yeah, that's right. Now I'm going to do that. See, we have so many get a perfect here. And I will say P total. E total. 1.0 second. And 8.5 second. 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 Now you get energy, total energy, right? So it's 5.0 times 8.5. Okay, that's the joule. Now you get 1 photon. H nu Hc lambda. So let's put the number, okay. 62634 joule second. And 2.99798 meter. And that one, it is 470 dots nanometer times -9 meter nanometer. Right. Now you get the N total, E total, and the E1. How many second figure? 2. So you should get 1.0 times 20. Okay. That's the way to do that. Okay. Right. Any question, class? Pretty good. So far, for those of you submitted your work, I'm very pleased. Now, if you make a mistake, that's okay. We are learning. That's totally fine. We learning, okay? We have a long way to go. Just keep doing. Go to next one. Getting harder. Getting harder, okay? Now it's getting harder, okay? I give you 3 minutes. So each question 1 minute. Now getting harder, okay? E photon, I did not calculate. See, and that's the one. See, that's the one. You do the calculation. I normally do the calculation in the last step. If we can cancel each other, let's make a calculation. It's easier. And that's the reason get you when I tell you before, even when I was in the college, we do not have a calculator. We have to use hand to calculate. So in this case, we try to postpone all the way. If we can cancel, then we do the calculation. Okay. Yeah, it's a 2 second figure. It is. See, why is it 2? Look at it. See, 5.0 joule, right? 8.75 second. Of course, here should be 2 second can be 2, right? Because it's a multiple. Right? It's a multiple. Got it? But because in the middle of calculation, if you want to keep one additional actual second figure, that's fine too. That's allowed when we do the data process, right? Very good, Katie. You did a great job, Katie. This is amazing. Thank you, William. Yeah, 1 more minute. Okay, everyone has a chance to do that. Remember, the photon, there's no, we discussed, there's no 0.1 photon. If you calculate the photon, it's 7.2, then you should put 71, not 70. If you have a 70.1, if you put 70, which means energy not enough. Got it? Oh, you said round up. How are you going to round up? 7.1 should be round down to the 70 now. If you put 70, then you get what? You do not have enough energy, right? You should round up. It's how I get confused. How are you going to round up? Here you look at it. Based the condition, the question. Okay. Let's do that. Okay. Let's do that. So what's the mean? So in this case, the minimum energy 2.70 times 10 to the minus 17. And that one will eventually reach your brain. Now, if I have a photon, how many photons? The wave length is 700. If wavelength 470, so which means that need more photon. Why? Because each photon have less energy. Each photon have less energy. You got it? And this one need less photon. Why? Because each photon has more energy. Now how can I do that? And I'm going to direct write out. Okay. A, you get 2.7 minus 17. Then you divide what? You divide h nu, right? Age 6.626. 33. Joe second. And 2.9979. 8th meter second. And you 700. And 10 to the minus 9. Right. And then you calculate, you get the 70.1. So how many photons? That should be 71 photons. Now, please do not get confused. 10 to the minus 3. Where is the 10 to the minus 3? No. No, should be this should be good. This should be good. This should be good. This should be good. Nanometer. Okay. Yeah. So why in this case is not run up? Why is not run up? And the reason is that you need a 70.1 photon. That's minimum NH. If you put a 70, you said, okay, run up, you get a 70. You know what? That NH not enough. So you need to run up, not down. It's the same way B. The same way, okay? The same way. Now, let me write out, okay? The same way. And how many? The 475 nanometer. You need to convert to the SI unit minus 9 meter nanometer. Okay. The latter one should be 48. Should be 48 photons. Okay. Okay, that's the way to do that. Okay, yeah. Now we're going to do more. Listen, when you do homework this time, please review your class notes first. If you can do all the questions, your homework should get perfect. Okay. Otherwise, you will say, "Oh my God, homework too hard." Okay. Now go to the next slide. It's getting harder. Class is getting harder. Okay. Now let me give you one thing. Okay, this one we did not learn before. 1 EV. 1 EV, which means it is electron volt, which equal 1.602 times minus 19 joule. I want you to remember this converting, okay? Okay, I want you to remember this one. We use all the time. 1 electron volt. EV equal 1.602 times 10 to the minus 19 joule. Now I give you 2 minutes. Good job. Rain, very good. It tell you here, Luis, let's give it to you, see. It's 1.602 times 10 minus 19. So it's different unit. This one is a common. all the time to use this one, electron volt, okay? Now, SI unit is equal this one, okay? I want you to remember, just remember it, okay? I did the same, I remember it. Yeah. Thank you. Thank you. Good job. Thank you. Good job. Okay, I'm going to do that, okay? I'm going to do this. The couple, these questions, couple things. The first one, now this new one, we learn something new. EV. EV, what's it mean? E is electron. V is volts. So the first one, we need to convert 1.82 gigawatt equal 1.82 times 1.602 19 joule. How many? You have 3 seconds in the figure. You get a 2.92 times 19. Give me slow down. It's a 19 joule. And we know work function equal what? H nu. Now you calculate threshold frequency equal VH. So you get a 2.92 minus 19. 6.22 times 34. The joule second. When you cancel second, you get a 1 second. That is hertz. Now it's a 3 second in the figure. So we get 4.40 times 10 to 14. Right. Got it. Let's do last one. Treat this one as the exam, okay? Treat this one as the exam, okay? A little bit of challenge, okay? Yeah. Now I give you 3 minutes, 4 minutes. Treat it as the exam, okay? Oh, sorry. Thank you. This one is not. That one should be 6 point. The Planck constant is 626. Okay, 6. That's right. That's right. That I get a feel confused with Avogadro's is 6.626. Thank you. Thank you. So many constants. That's right. That's right. That's right, Louis. No, everyone needed to do the calculation, not the member. You needed to do the calculation. Thank you. Yeah, I give you 2 more minutes. Okay, so you're going to do this question. Thank you. 40 seconds. Okay. Good job. Good. Okay. I'm going to do that. Okay, class. Now, this question is about what? See, did you see the mentioned kinetic energy of eject electron is this Joe when this light? And we change wavelengths, that's the one. Should be less. So you need to calculate Planck constant. You need to calculate, not memorize. You need to calculate threshold frequency. Then you need to calculate the work function. Okay, now let's do that. The equation for this question is that kinetic energy equal h nu minus h nu naught. Right now, so that's the one. Now, in this one, see kinetic energy. So 1, you get h nu 1. Work function should be same. Minimum energy required should be same. Okay. Now let's look at kinetic energy 2 equal h nu 2. Now if here it is a 1, here is a 2. 1 minus 2. So it's a kinetic energy 1 minus kinetic energy 2 equal what? Equal h nu 1 minus h nu 2. Now in this case, let's see, it's a 2.935 times minus 19. You look at the class what we did, step by step, right? Then minus 1.280 times minus 19. Now what's this? H we can take out. We can take out. Now nu 1 nu 2. You got it? Right? So now if you do the math, and that equal what? It's 1.6. 1.6. Hold on. Is it right? What? Yeah, I think so. 1.655 times minus 19 joule. You get the H. Now what's this? 1 lambda 1. 1 lambda 2. Right? Now what are you going to do? You just H lambda 1 equal what? 300 dot times minus 9 minus 400 dot times minus 9. And in this equation, that's the only unknown. So you calculate the H, you calculate, right? You should get 6.625 times minus 34 joule second. And that your answer, okay? That your answer, okay? And you said, oh, no. That one, oh, yeah, they do have a C. They do have a C. The C should be in the top. Lambda is C should be here. Yeah, they do have a C. That's right. They do have a C. Okay. Yeah, they do have a C. And we can take a C to here. We can take C to here. Okay. Right. Now, and you said Y is not equal 6.626 because when we do the measurement, we may have some error, right? We may have some error. Got it? Okay, now go to next one. Now I move to this side, okay? So we done the A. Now you go to the B. The B, the threshold frequency, can I just use any one? Use this one. Use 1 or 2. Let's use 1, okay? So basically it's a kinetic energy 1. Oh, I'm going to slow down a little bit, okay? Otherwise make a mistake. Equal H nu H lambda. So basically you calculate this one. You calculate this one. You got it? Now calculate this one. Well, what's the mean, Henry? Disable reactions. What's the mean? I don't know how to do that. I don't know where is the reaction. Oh, Jensen, please do not have a reaction. Okay, please, I don't know how to do. Please in the class. That's why, as I said at the beginning class, that's why I disabled you guys to communicate each other. You can direct communicate to me, only to me. And it's a reason in the previous, before I disabled, each week I go back to check the checking box. What do you track? You checked, you talked, right? Got it? Yeah, please. Yeah, that's right. Also, someone use random music. Okay, please do not do that, class. Yeah, this is second time we say, please, I love you guys. You come to the class. We are going to do the best chemistry. Okay, this is sum. We did not take a whole sum off. We just learned the best chemistry. Right. So let's do that, please. Okay. If you need help, you have a question, I will help you. Okay. Yes, I did. Now let's do that. Okay. So we need to find this one. How are we going to do that? See, you can give the formula. So I can do this. It's a multiple way to do that. Okay. If you want to step by step, it's the same. You get what? You got minus, then you divide h. That's the way. Now let's put the number, then we do calculation. Okay. The number is 6.62634. Okay. Right. That's the one. 34. Now let's find the wave number. Should it be 300? You times 10 to the minus 9. Then you minus kinetic energy 1 is 2.935 times 919. Then you divide the 6626 times 34. Now, in this case, now you are going to find the answer yourself, okay? So I did it for you. I did it for you, okay? So you got 564 and 14 hertz. Okay. So that's the B. Now, once you have a B work function, it's so easy to do that. Okay. So easy to do that. Right, that's the work function. Now you put the number. You put the number. I'm not going to do that, okay? Now you put the what? You put the H. Then you put this number. Okay, you put it. You put it. Now you get a what? You get a 3687 times minus 19. Okay. Now if we, some of you said, can you write slow down? As you are right. I need to slow down. Now if you want to convert to electron volt, so you get 2.301 electron volt. You do not have to, if you want. Now, how can you do that? Basically, you divide 1.602 times minus 19 joule volt. As you know that, did you remember? I can cancel this one. Now you just do the math, do this one. So you get this. Okay. This is an amazing question. This question. Now I want to stay here a minute. So you're going to make the notes. Yeah. Any question, please? Now let's move on. Okay. We're going to learn as much as we can. Okay, each class. So we finish. Now, did you remember, look at the class notes? Every session, we will have a summary. The summary, we begin in blackboard radiation. We did not discuss very detail. However, we discussed the hydrogen lamp. From blackboard radiation, Planck proposed quantum mechanics. See, they said quantization of electromagnetic radiation. That's in a theory. Now, the photoelectric effect proved evidence, which is particle. The electromagnetic radiation not only have a wave, but also have a particle. Right? Quanta photon electron effect, it is a particle. And the wave diffraction is a wave. So we learned two parts. Until this point, we know very well. We have light, you have a particle, and wave. So we call it duality. Not only that, but also we can expand. Not only the wave-particle duality is not only for electromagnetic radiation. not only for the wave, for the light, we extend it to the matter. See the science. At the beginning, it's very nano, only for electromagnetic radiation. Now we are going to expand. See, what's this? And that is a wave. What's this? That is a particle. Remember, the wave, you have a lambda, frequency, speed of the light, and diffraction. Diffraction, okay. So anytime people tell you diffraction, you said that's the wave. Anytime people said frequency, that's the wave. Now, particle related to what? Related mass and velocity. Such as in a minute, we're going to discuss called linear momentum. That's new stuff for some of you, okay? Linear momentum, that is a particle. That is a particle. Kinetic energy, that is a particle. That is a particle. Kinetic energy is what? It is 1/2 mv squared. Okay, right? So wave particle. Now, who did combine these two? Frenchman. Actually, it's a French young man. That time, I think only 28 years old, very young. He proposed all particles, all, not only electromagnetic radiation, all, remember all. You have a wave property and a particle property. Not only that, he proposed its mathematical equation. And this equation called de-Broglie equation. So how many equations we learn? We learn Einstein equation. Now we learn another equation today, de-Broglie equation, which is lambda equal h divided p. P, it is a linear momentum. P equal what? Equal h mv. Now, what's this? That is a wave. What's this? That's the particle. And the wave particle, wave and the particle are connected by Planck constant. Now in this equation, wavelength is not just electromagnetic radiation, it is a matter wave. I'm matter wave. Matter wave. What's the mean matter wave? Did you remember in the chapter 1 we said what is matter? You have mass, you have a space. That's why. So that wave is not just electromagnetic radiation. We extend. It's called matter wave. And that's the equation you need to remember. You need to remember. Today, I did not assign your homework to this equation. Why? We will not have time to do the practice. But next week, we will continue from here. Then I will assign your homework. Next week, the homework also, this week probably, I forgot. I signed it this morning. So you need to use Schrödinger equation. Now, today we learn a lot. Some question is high level. Now, before that you go, I want to give you a minute to ask a question in case you cannot do the homework, right? Yeah. ask any question you can ask now. Now? Okay. Any question you can ask. Okay. Now listen, we do not have office hour this week. C is the speed of the light. Right? No, you have to. You calculate the threshold frequency. You have to use work function. Why? See? Right. That's it by definition. If you did not know the work function, you cannot do that. Got it? Right? Which answer? Answer here. Right? Or here. Which one? You can use. That's the C, right? Because you know the threshold frequency, then you know the Planck constant. See, you can use Joule, you can use electron volt. Okay, right? Yeah. So please prepare of chapter 2. We are going to have an exam. Okay, the final exam in the chapter 2. Good luck. Good night. Bye now.
Bye.
I think
Bye.
you.
Bye.